So the next proof technique is proof by contradiction. The idea is we assume the negation of the statement we want to prove, and from that deduce that something is obviously false. So let me try to illustrate that with a small example. There are no positive integers x and y with x and y larger than 0, such that x squared minus y squared equals 1. How can we prove that? Well, we negate the statement, which would mean that we assume that positive integers exist such that x squared minus y squared equals 1. We can rewrite this first part by as x plus y in brackets times x minus y in brackets. So since both are integers, then both of these numbers are integers too. So we have two cases. X plus y equals 1 and x minus y equals 1. That's one way how the multiplication can end up as 1. If we solve this pair of equations, this gives us x equals 1 and y equals 1. However, this contradicts that x and y are larger than 0, as we initially assumed. On the other hand, case 2, x plus y equals minus 1, and x minus y also equals minus 1. This is the second case. If we multiply minus 1 times minus 1, we actually get 1. Solving these again, we find that x equals minus 1 and y equals 0, again contradicting that x and y are larger than 0. So in total, we showed from those two cases that in every case this leads to a contradiction. So in summary, we can conclude that the negation has been disproven, and therefore our initial assumption, our initial sentence has been proven. A problem that becomes important if you do proof by negation is how do you, or proof by contradiction, is how do you determine the negated formula, the negated statement. And in this table, I show you some typical cases that have to be taken into account. So A or B, if you negate it, it gets you not A and not B. A and B becomes not A or not B. If A then B gets A and not B. The quantification is also something you basically have to know or learn. So for all x, f of x holds becomes, if negated, there exists an x such that not ax. Similarly, there exists x such that ax becomes for every x not ax holds. So that means the quantifications, the all quantification becomes an existence quantification, and the existence quantification becomes an all quantification if you negate the values. So how do you spot that this is time for a proof by contradiction? Well, the typical case is first you try to do it directly. That's always the most straightforward thing people try. If you cannot do it that way, then it's a good practice simply to say, well, what would happen if this would not hold? And then you are in the middle of doing a proof by contradiction. So it's a kind of trial and error technique, typically starting with the direct proof and doing the proof by contradiction second. So how do you write it down? First, you state that you are assuming the statement is false. That's basically when you announce, I'm now trying to do a proof by contradiction. You write out the false statement by negating it, so it's very clear what you really want to prove. Then you work out the various implications of that, trying to identify a contradiction. Once you find a contradiction, something that just cannot be, then you announce that a contradiction has been found, and you conclude that the original statement was indeed correct. In this third step here, this implication, you can actually then just use again any of the other techniques that we introduced throughout this lecture or that exist as a whole for proving.